In our first ibaAnalyzer tutorial, we will show you how to open a measurement file, analyze it, and prepare it for evaluation. Finally, we explain how multiple files can be viewed and compared simultaneously to efficiently analyze production processes. We start with the selection and preview of a suitable file, add digital signals, and use filter and comparison functions for detailed process analysis. Let's start by opening a suitable measurement file. As this example is about the manual evaluation of a hot rolling process, we open a suitable product file. In other words, a triggered recording that contains exactly one product cycle. In the open dialog, we navigate to the location where our measurement files are stored. To avoid navigating to this location every time in the future, the storage location can be set as a favorite. In future, we will be able to select it directly from the drop-down menu. Of course, favorites can also be created for different storage locations. In order to select in advance which measurement file is of interest, individual signal curves can also be shown in a preview. To do this, the preview window must first be switched on. A signal can then be selected from the signal tree and dragged into the preview window. Depending on which window is currently active, you can either switch between the individual signals or between the individual files using the arrow keys. These options make it much easier to select the right measurement file. When the right file has been found, the dialog can be closed by clicking the OK button. The selected file is then opened in ibaAnalyzer. After opening the file, the entire recorded signal spectrum is available in the signal tree. To begin with, let's look for a signal that sufficiently describes the production process, for example, a rolling force. The signals can be displayed differently in ibaAnalyzer as a plain list or sorted in modules or in signal groups. By default, the signals are displayed in modules, which corresponds to the sorting as they were configured in ibaPDA via the individual interfaces. Showing signals sorted by signal groups can also be very interesting, as the assignment is freely definable. You can switch between the different view modes via the context menu. The folder structure has to be defined in ibaPDA. If this has not been done, the grouped view will show all signals as ungrouped. In our case, meaningful groups have been defined in ibaPDA, and it makes sense to stay with this type of view. If you are not sure where to find the force signal, you can use the signal search in ibaAnalyzer. This search is iterative. If you search for force, for example, all signals containing the word force are returned. You can then filter further, for example by finishing mill. The signals can be dragged and dropped from the search result into the trend. This applies to both individual signals and multiple signals. If there are several signals, holding down the Shift/Control key allows you to conveniently choose between a separate or common y-axis. Let us first restrict ourselves to a single signal, the rolling force of the first rolling stand. A digital signal is often helpful for further analysis, e.g. to indicate the stand assignment. If this signal is not already contained in the recorded raw signals, ibaAnalyzer also offers the option of adding virtual, calculated signals. Let's take a look at this using the rolling force as an example. By right-clicking in the signal definition table, we add a new signal and name it. The expression can either be entered directly in the corresponding cell, if you are familiar with the syntax. If not, the expression can also be created using the expression builder. Here you will also find more information on the available functions. In our case, the expression is quite simple. The force signal is simply checked for a value greater than 50. The return value is then true or false. If you drag the new signal into the upper trend, you can immediately see that the result matches the signal curve. Such digital signals are very easy to work with as they are simple to use for many functions. For example, they contain information on the runtime, meaning the occupancy time of the stand. Simply double-click on the relevant signal area to show or hide the runtime immediately. Although this option is very simple, it only applies to the currently open instance. If these runtimes are always to be displayed automatically, they must be calculated. One of the following tutorials will explain in detail which functions are required for this and where this calculation is carried out. Such a digital signal, which describes the period of a production interval, has further advantages. With the help of the two edges, the intervening period can be evaluated very easily with regard to the minimum, maximum, and average values. If you switch to the Marker tab, the markers X1 and X2 can easily be set to the edge by holding down the Control key. The difference values between the two markers can then be seen in the marker table for each signal displayed, both for the time values on the x-axis and for the values on the y-axis. The same applies to the statistics table, where the minimum, maximum, and average values can be taken. The statistics are always evaluated for the time range between the two markers. If the position of the markers works in a different way when the control key is pressed, it is probably just a problem with the settings. Under the menu item Setup and Preferences, you will find various settings for the behavior of the marker. In our case, the middle setting is required. Remember to check the box when applying the settings, otherwise the adjustment will only take effect the next time you restart ibaAnalyzer. If you want to compare several products of an order, you can also open several files at once. There are various ways of displaying these depending on the requirements. In the first case, the files should be displayed one after the other. So let's call up the Open Dialog and select different measurement files. However, it is now important to check the box for the append function. Once we have exited the dialog by clicking the OK button, we can see the result directly in the already open trend. All product files are displayed one after the other, with the vertical dashed lines marking the file borders. Between the individual products, you can see areas that are empty. These are the time periods that lie outside the product sequences, so we are missing the process data for these intervals. If these products are produced in a quick succession, the gaps may be irrelevant. If there is a disruption lasting several hours in between, you would probably prefer to hide the gap. This is also easily possible if time synchronization is deselected by right-clicking on the x-axis. Another way to compare several files with each other is to open them in parallel. First, close all open measurement files via the context menu, and then call up the Open Dialog. We select a few measurement files again, but remove the check mark for the append function. Then we leave the dialog again by clicking the OK button. The result looks like in the first example, the individually opened measurement file. In the signal tree, however, you can see the selected product files. These are all arranged in parallel, each with its own signal tree. Let's add the force signal from the second file to the trend. A difference can then be seen directly in the signal definition. While we only had one signal tree in the first two display variants, we now have several. Therefore, a suffix is required to differentiate between the signals in the measurement files. This can be seen very clearly in the selected signal. While the first signal contains only the module and signal number, the signal of the second file has the suffix 1_, the third file would therefore have the 2_, the fourth the 3_, and so on. This representation has a disadvantage. Each force signal of a file would have to be addressed individually, which is certainly a lot of work if there are more than a couple of files. In such a case, the wildcard function can be used. This function makes it possible to access all open force signals with just one call. The call is made with the suffix *_. In this case, it also makes sense to switch off time synchronization via the context menu of the x-axis. It is then immediately possible to determine any process scatter. Once an outlier has been detected, it can be assigned to the respective measurement file via the Search tab and the selection of the target crosshairs. Now we come to the last comparison option, the file group. After we have closed all measurement files, we can call up the Open Dialog again. Here we find the window for the file group in the lower part. Now we can select measurement files from different folders and drag and drop them into the file group. They can then be opened from there. The result is very similar to the first example, but all other files are already open in the background. The respective measurement file can now be selected either via the drop-down menu or using the arrow keys. Although each product file can be evaluated on its own, it is possible to switch to another file very quickly. I think this is enough to give you an initial idea of the possibilities, even if we have only seen a fraction of them. Further possibilities for evaluation and automation will be presented in the next tutorials.